In this video, let us have a look at one last example. Raju has a savings account in a bank. Raju owes rupees 50 to the bank, and each month rupees 10 is deducted from his account for not maintaining minimum balance. How much would Raju's bank balance show after a given number of months? Let us visualize this problem. This here is Raju, and he owes to the bank a sum of rupees 50. This means that whenever he checks his bank balance on his mobile phone, his bank balance would show minus 50. This minus here means that he owes to the bank a sum of rupees 50, right? That is simple. So now let us form an equation for his bank balance. His bank balance after at any given point would be equal to, well, currently he owes to the bank a sum of 50 rupees, which means his bank balance is minus 50. But the question asks us to find how much would Raju's bank balance show after a given number of months. So now the given number of months could be anything, which means it's a variable. So we use a letter to denote this variable, x as usual. Now, because after each month rupees 10 is deducted from his account for not maintaining minimum balance, after x number of months have passed, 10x rupees would be deducted from his bank account, right? So we'll have to reduce 10x rupees from his current bank balance to find his latest bank balance at any given point, right, after x number of months. Now BB, bank balance, is a variable, so we use another letter y as usual to denote it. So y equals minus 50 minus 10x. Now to keep things uniform, we rearrange the terms and write this as minus 10x. I just write this term before, and let's say I'll write this term after this, minus 50. And that there is my equation. Now as usual, I'll draw a table for this, and let's say we'll find out the bank balance of Raju in three different cases. Let's say after a single month has passed, after 2 months have passed, and after 3 months have passed. So firstly, let us have a look at what the equation will be after a single month has passed. The equation becomes y equals minus 10x, x is 1, so 10 times 1 minus 50. This gives me y equals minus 10 minus 50, y equals minus 60. Raju's bank balance would be minus 60 after 1 month has passed. Now after, let's say, 2 months have passed, the equation becomes y equals minus 10 times 2 minus 50, and this becomes minus 20 minus 50, and so y equals minus 70. So Raju's bank balance is minus 70 after 2 months have passed. Lastly, when 3 months have passed, the equation becomes minus 10 times 3 minus 50. So y equals minus 30 minus 50, y equals minus 80. So after 3 months have passed, his bank balance would be minus 80 rupees. We'll put that in a table, and lastly we can plot this information on a graph. Now we've done this enough number of times in the past, so here I have the graph, and let's say let's choose the color red. So on this x-axis I'm plotting the number of months, and on the y-axis, this is the negative y-axis, right? This part would be the positive y-axis. So on the y-axis I am plotting his bank balance. Let's just call it BB, and I am not going to go through the whole process, but this would be the first point, which is 1 comma minus 60, and you can pause the video and verify it yourself. This is 1 and this is minus 60 right here. This one would be 2 comma minus 70. Minus 70 is there, and the last one is 3 comma minus 80. Confirm it yourself. Just pause the video and have a look at it. I label 3 points, and I draw a straight line through the 3 points, and we can again see that the 3 points lie on a straight line. I can take another point, let's say this point. This point is 0 comma minus 50, right? It's 0 on the x-axis and minus 50 on the y-axis here, and 0 on the x-axis. And if I look at my equation, y equals minus 10x minus 50, I can see that when x is 0, so when x is 0, our equation becomes y equals minus 10 times 0 minus 50. This term becomes 0. I have minus 50 there, so y equals 0 minus 50, which is y equals minus 50, and I can see that y is minus 50 actually. So this point is indeed a solution to this equation, and that just reinforces the idea that all the solutions of a particular linear equation lie on a single straight line. In other words, if I plot all the solutions of this linear equation, I would get a straight line.